Hello everyone, welcome to Young Innovators Astronomy class. In this video, we shall be learning about the concept of rotation of Earth and how time is calculated based on it. From the time we wake up until we go to bed, we constantly talk about time. In a way, it helps us measure our work on a daily basis. But did you ever think who began the time with 6 a.m. in the morning? Why is our daily routine scheduled in that manner? Is the time same throughout the world? Does everybody wake up and work at the same time? Let's look into it in detail and learn about it. Throughout the globe, all living beings are synchronized with the movement of Earth. As the Earth spins and one receives sunlight, we call it day, and as sunlight diminishes or disappears, we call it the night. Earth takes about 24 hours to complete one rotation, 12 hours per day and 12 hours for night. Day is the period between sunrise and sunset. It is the period when we can see all things around us without an artificial source of light. After sunset in the evening, as the Earth completes its 12 hours of its cycle, the sunlight decreases. Nature goes dark and it becomes difficult to see the objects around us without light. This is called night. Day and night does not happen at the same time and same place throughout the world. It is considered based on the sunlight or sun rising and setting time. Our globe is spherical in shape, divided by two circles, namely equator drawn from east to west and prime meridian drawn from north to south on the surface of Earth. The sphere divided by the line into two halves by the prime meridian is called as eastern and western hemisphere, and the line divided from north to south is called the northern and southern hemisphere. Due to the rotation of Earth, the day and night is dependent on the hemisphere facing the sun or sunlight falling on it. Our globe can be divided into two halves based on the sunlight falling on it, one which is facing towards the sun, another facing away from the sun. One part which is facing towards sun will have a day and other will have night as Earth rotates. Part which is facing away from sun will face sun and it will be day for it. Similarly, night for other part. So to measure the exact beginning of the day and night, we consider the lines on the globe. Have you noticed the lines or grids on the globe? Did you observe the numbers mentioned on it? That's how we measure time. Lines on the globe run from North Pole to South Pole and east to west of the equator. Lines drawn from North Pole to South Pole are called as longitude lines, and lines drawn parallel to the equator or east to west are called as latitude lines. Both longitude and latitudes are divided in degrees. It begins from 0 degree at the equator and ends at 90 degrees close to the pole. Lines above the equator in the north are measured with positive sign, and lines below the equator in the south are measured with negative sign. We know that sunlight does not spread uniformly on the globe. It depends on the latitude and longitude. Hence, at polar regions we have different night and day periods. Each planet in the solar system has different rotation periods, hence different length of day and night. Though we cannot go to the planet physically, we can measure its rotation by measuring its spin. Let's see how length or duration of day and night varies on different planets. Let's choose Mercury, whose one rotation period is close to 58 days. If we have to compare with Earth's rotation period and divide the day and night period for the planet Mercury, it will be too long. Let's look into it. Daytime on Earth is the period between sunrise and sunset, and nighttime on Earth is the period between sunset and sunrise. Starting from the sunrise, the time taken for the sunset to be seen on Mercury is about 88 days, as the Mercury spins slowly. That means 12 hours of day cycle on Earth is equivalent to 88 Earth days on Mercury. It is indeed too long, because as the Mercury spins slowly, the time taken for the sun to appear above or below the horizon is very important for the day and night periods. Due to its long period of rotation, every position of sun will be for a long time. In the case of Jupiter, it spins so fast that it takes about just 10 hours to complete one cycle. so we have only 10 hours to see both sunrise and sunset on the planet. As outer planets spin faster compared to inner planets, the rotation period of outer planets are less, and sunrise and sunset will happen for very few hours only. This tells us that time is dependent on the planet that we live and its speed of rotation. Just imagine if we were on Jupiter. Our school time would have been for less than 2 hours, and on Mercury it would have been for days. Oh no, I don't want that. Luckily, we are on a planet Earth which takes sufficient time to rotate and provide us with enough sunlight to sustain. So planet Earth is upright as life is possible only here as of now. Hence, it's important that we do not disturb, destroy, or harm our planet. Thank you for watching.